Hi guys, in this video I cover binary representation. Let's understand what binary means. Binary consists of bits and each bit is either 1 or 0. When the bit is 1, it is turned on, and when it's 0, the bit is turned off. Many times you also hear the term byte. A byte consists of a sequence of 8 bits. Now let's take a look at an example. Here you see a bit that's currently turned off. We can also turn the bit on by flipping it to 1. Now in the next example, you see a byte. This is a sequence of 8 bits that are all currently turned off. Each of these bits we can turn on or off by flipping it to 1 or 0. We could also turn all the bits 1. In that case, the byte would consist of 8 bits that are all 1. Now, the rightmost bit is often referred to as the least significant bit, and the leftmost bit is often referred to as the most significant bit. Now, in this example, the least significant bit is turned on. We can also turn on the second least significant bit. In this case, it would end with 1 and 0. Or we could turn both of them on. And we really can turn on any bits in this byte. Now, obviously, we can represent a byte, 8 bits, 10 bits, whatever we currently want to represent. There's no limit to the numbers of bits, just like there's no limit for decimal numbers, right? We can represent up to 100, up to 1,000, up to 1,000,000, whatever our use case currently requires. Now, when we have a certain number of bits, how many values can we represent? Now, with a single bit, I mentioned this bit can be 0 or 1. So we have a total of 2 values that a single bit can represent. But let's take a look how many values we can represent with 2 bits, 3 bits, and so on. When we have 2 bits, we can represent these 2 bits as 00, 01, 10, and 11. So we have a total of 1, 2, 3, 4 values that we can represent with 2 bits. What you'll notice maybe is that we have the least significant bit in these 2 bits is 0, 1, 0, 1. And the first 2 examples or values here, it's prefixed with 0. The second 2 it's prefixed with 1. So essentially, we always use the last values from the last bits that we have, in this case 0 and 1, and just prefix it one time with 0 and another time with 1. So when I add an additional bit, I would take these 4 values and one time add 0 in front, and then take these 4 values again and add 1 to the front. That's one way of coming up with the values quickly. So here is 3 bits. 0, 0, 0, 0, 0, 1, 0, 1, 0, and then would be 0, 1, 1, 1, 0, 0, and so on until we reach 1, 1, 0 and 1, 1, 1, to the total of 8 values that can be represented with 3 bits. Now, how many bits can we represent with 4? How many values can we represent with 4 bits? What you may have noticed is that each time we add a bit, we double the values that we can represent. With a single bit, we had 2 values. 2 bits, it was 4 values. 3 bits, 8. And so 4 bits would be 16 values. Again, we doubled from 8 to 16. And essentially what happened is we took all the values for 3 bits. One time we added 0 in front, and one time we take the values and add 1 in front, with the 4th bit being 0 or 1. Now, if we have 5 bits, we can represent 32 values. 6 bits, 64, 7 bits, 128, and 8 bits, 256 different values. Now, with all these values, how do we represent a decimal number? So let's take a look how we represent numbers. This is another example how we can show the different values and how we count up. Essentially, we have 3 bits here. They are all turned off in the very first row at the top. Now the next row shows the least significant bit that's turned on. Then the middle bit is turned on and the least significant bit is turned off. Essentially what I'm doing here is I'm counting up. So all of them 0, I add 1 to it. In binary, I only have 0 and 1. So there are no more values that I can represent in this bit. So I go back to 0 and I have essentially a carry or the next value here that I represent in the next row, in the next bit. This I turn on and then I do the same thing again. 0 and 1. Now I reach the end. So I take the third bit and I turn it on. And I have 0, 0 and then 1, 0, 1. Now, if you think in terms of binary, we actually do the exact same thing. With the least significant digit, we start counting 0, 1, 2, 3, 4, 5 until we reach 9. We have no more values that we can represent with a single digit. So we take the next digit, turn it to 1 and start at 0 again. This would be 10 in decimal. And then with the least significant bit, we start counting again from 1 through 9. So 11 to 19. Once we reach 19, we count this up to 2, and then we go all the way to 99. Once we reach 99, we flip it to 100 in decimal. So we always, with each digit, we count up to all the values that we can represent. Just in binary, we have only 2 values that we can represent it. So it's always 0, 1, 0, 1, 0, 1. What you'll also notice that there's a pattern. The least significant bit is always 0, 1, 0, 1, 0, 1, 0, 1. The next second bit is 0, 0, 1, 1, 0, 0, 1, 1, and so on. And the next one will be 0, 0, 0, 0, 4 times 0, followed by 4 times 1. Then 4 times 0 again, 4 times 1. The fourth bit, if it were here, it would be 8 times 0 followed by 8 times 1. So this is the pattern that you'll see. Now how are decimal numbers represented? This shows 0 in binary. So we have 8 bits, so 1 byte, all of them 0. The least significant bit represents a 1. The second bit represents 2, 4, 8, 16, 32, 64, 128. Now if we want to represent decimal 4, for example, we would just flip this bit to 1. That means we have the 4. If we want to represent 2, we flip this bit to 1. If we want to represent 1, we flip this bit to 1. If we want to represent 32, we flip this bit to 1. So whatever bit is flipped or turned on, that's the decimal value we get. Now, how can we represent, or how can we get a decimal number for a decimal that's not represented here for a bit? So for example, what if we want to see 12? All we do is we take 8, turn it on, and then turn on 4. So we can turn on multiple bits. This would give us 12. So let's look at an example. Let's say I turn the least significant bit on. This gives me 1. Now, if I turn the second bit on, this gives me decimal 2. If I turn on both of these, I would get 3. And if I turn on 8 and the 1 here, this would give me 9. Now, how would you represent 15? 15 is represented by turning on 8, 4, 2, and 1, right? We get 8 plus 4, which is 12, plus 2, 14, plus 1, this is 15. And the next value would then be 16, where this would be turned on and all these would be flipped back to 0. Now another way to write this is basically 2 to the power of 0, right? Anything to the power of 0 is 1, so this is 1. 2 to the power of 1 is 2. 2 to the power of 2, which is 4. 2 to the power of 3, power of 4, 5, 6, and 7. And when we are aware that everything is to the power of the position of the bit, then we can also write it like this. Let's say we have eight bits. The one that represents decimal 16 is turned on, and the one that represents decimal 1 is turned on. So this represents 17. And how would you calculate this? 1 times to the power of 4. This is the value I have here. 2 to the power of 4 is 16. Plus 1 times the power of 0. 2 to the power of 0, which is 1. So we have 16 plus 1, and this gives us 17. Now, what if given a decimal number, how can we come up with the binary representation? So if I give you 17, how can you come up that it's 1, 0, 0, 0, 1? The way this works is we take the decimal number divided by 2 and we track the remainder. And we repeat this until the result is 0. Let's take a look at an example. Let's say we have the decimal number 2. We take 2 divided by 2, which is 1, and the remainder is 0. Now we take this result and divide it by 2 again. So we take 1 divided by 2, which is 0. We only deal with integers, so there's no fractions. So this is 0, and we have a remainder of 1. Now the result is 0, and we are done. What we'll do next is take the remainders and from the bottom to the top read them out. This would be 1 and 0. 1, 0. This is our binary that represents 2. Now let's look at another example. Let's say given the decimal 15. You may want to pause the video and try this out for yourself. What I do here is I take 15 divided by 2. This gives me a result of 7 with a remainder of 1. Now I take 7 and divide it by 2 a second time. This division gives me 3 with a remainder of 1. Again, I take 3 divided by 2, which is 1. Again, with a remainder of 1. I take 1 divided by 2, this is 0, with a remainder of 1. And this is now 0, so I won't divide any longer. This is the result I get, and I read this from the bottom to the top, which is 1, 1, 1, and 1. So this is the binary representation of 15. It's 4 bits, all of them are turned on. And when we look here, this is what it looks like. If I have, for example, 1 byte, the last 4 bits would be turned on. 1, 1, 1, and 1. I could also represent this with just 4 bits. I don't need 8 bytes to represent 15. But since all of these are turned on, we can convert it back, which would be 8 plus 4 plus 2 plus 1. This gives us 15 in decimal. I hope you enjoyed this video. Thank you for watching.